For Module 14.1, Law of Sines. So our essential question is how can you use trigonometric ratios to find side lengths and angle measures of non-right angles? So notice the key word, right? Non-right triangles. So our shortest answer is basically we use the law of sines. This allows us to find unknown side lengths and angle measures for any given triangle, as long as you know that it's angle, angle, side, angle, or even side angle for its information. So you can just use the law of sines and find those missing little pieces. So let's examine where a lot of sines derive from, or where it comes from. So if you recall back to the area formula, all right, so let's say we wanted to find our reference angle from angle A. Okay. Maybe they give us a degree or something like that, and we have to find the area. Well, you have to know the two sides first, all right, along with the degree of angle A, and that will give you the area for that whole triangle. Now, in this situation, we are going off the reference of angle C. And if you look at our reference angle here, its two sides that are right next door, right, are A and B. So the area formula for this scenario would also be 1/2, but instead of B times C, it'd be A times B, and then times the sine of angle C. Very familiar. Now, if we change it up, if our reference angle is now angle B, if you notice his two sides that are next door are A and C. So the area for that triangle would be very similar. Be 1/2 times our next door sides, which is A, times C, times the sine of angle B. Now, what's interesting is this is all the same triangle. All three of these triangles are the same. They are similar, or they are congruent. How about that? Congruent's a better word. So in that situation, what do we know about the area for all these situations? They're all the same, right? So since the area of, again, angle A in reference, okay, B times C times sine of A has to be the same as 1/2 times A times B times sine of angle C, right? If they belong to the same triangle, then all their area formulas should give you the same answer because it's the same triangle. And then lastly, 1/2 times A times C times sine of angle B. They all have to be the same. They all have to equal each other. All right. Now let's clean this up. Let's see. They're all multiplying by 1/2 or dividing by 2. What's the opposite or the inverse of dividing by 2? Multiply, yes. And then let's clean it up. Almost every term is multiplying by A, B, or C. So I want to go ahead and what's the opposite of multiplying by A, B, or C? It's dividing by A, B, or C. And now I'm just going to distribute, okay, distributive property to clean it up. So if I do that, let's see, this B cancels out with that B, and that C cancels out. That A is still there. So we're going to have sine of A. Notice how the multiplying 2 will cancel out the 1/2s. So you have sine of A over side A. All right, middle term. I see the A cancels out, the B cancels out, but the C is still there. So we have sine of C over the side of C. Okay, so big C is the angle. Just remember, big letters, angle. All right, vertices. And then lastly, A cancels out with that A, C cancels out that C, and all that's left is that B. And again, the 1/2s just magically disappear because we multiplied by that 2. And then we have sine of angle B. All right, so da 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 da. That, ladies and gentlemen, is where this law comes from. All right. The fact that we're using the area formula, and again, if you look at these, the the whole triangle isn't stated to be a right triangle. So that's pretty nifty because the law of sines doesn't necessarily have to be, bounded to right triangles. It could work with non-right triangles, like the essential question stated. All right. So make sure you know how to derive the law of sines. Again, also remember the area formula. That's where it all comes from. All right, so let's apply the law of sines. So again, here is the law of sines. I showed you where it all came from. And basically, it's like this. You have to make sure you have a situation where you have angle, angle, side, or angle, side, angle type information in order to even set up the correct setup. All right, so setup for the correct setup. Interesting. Or you could do side side angle. It's pretty rare that you see that, but it happens. Now, so let's see. We have what angle, angle, side. Okay, so that actually works, right? So this is what I'm going to do. All right, now sine of, how about this? Notice how if you have the 35 degrees for angle R, if you go across on the opposite, you actually have um, a given number for you. So you would have the sine of 35 degrees over the 15. All right. Now, that's good. So let's see. Let's try to apply the law of sines to figure out another angle. Now, real quick, you can actually find angle T, right? By knowing that a triangle has to have the sum of 180 degrees. And we already have 35, so we'll subtract that. We already have 38, so we'll subtract that. And we'll subtract it from 180. So again, 180 minus 35 degrees, and then minus 38 degrees, and you should get 107 degrees. Okay, good to know. And I'll tell you what, I'm gonna find I'm gonna find t first. All right, so I'll find t. Yeah, that sounds fine. So I'll tell you what, I'll do sine of 107 degrees over t. Okay, so that'll help me find t first. Um, Now you could do the whole cross multiplication. You'll get t times sine of 35 degrees equaling 15 times the sine of 107 degrees. Ask that question, how do you get rid of a multiplying sine of 35 degrees? You should get division right away, but just remember what you do to one side, you have to do to the other. Now, this is really tricky. If you try this in the calculator, you need to be careful. Um, this is where you can really, really just, mess up. So you could do, let's see, make sure I don't mess up, right? So 15 times sine of 107 degrees. All right, looks good. Divided by sine of 35 degrees. All right, and you should get, and it looks like we round to the nearest tenth. So attention to detail, okay? You should get 25.00. So 25 works just fine. All right, so t equals 25. Good to know. Now, if we were to solve for s first, okay, so again, this was for t. All right, Mr. T, pity the fool. You guys are probably too young to know what that is. Oh, now I'm sad. All right, here we go. Now let's solve for s. All right, so you could use sine of 35 degrees again over the 15, but instead of sine of 107, over t, we're solving for s. So if you look at angle s, he has 38 degrees. All right, so sine of 38 degrees, and on the opposite side of sine of 38 degrees, we have s. Sorry if my 5s look like my s's. So again, cross multiply, you'll have s times the sine of 35 degrees equaling 15 times the sine of 38 degrees. How do you get rid of a multiplying sine of 35? Divide, and what you do to one side, you must do to the other. All right, so be careful with the calculator again. Let's see here. We have 15 times sine of 38 divided by the sine of 35 degrees. Please remember, though, you need to be in degrees. Okay, so S should equal 16.10, round to the nearest tenth, so 16.1 works just fine. So I know you're like, Mr. Webb, I see 3 things equaling each other, and you only have 2. And that's legit because it's a good question. You know, you only have 2 things equaling each other, and the law has 3. In this case, it's really just saying the angle of this guy divided by that guy should be equal to this angle divided by that guy, or this guy divided by this side, all right, that angle divided by this side should have the same ratio. So knowing that, it kind of helps you find the missing pieces. All right, so example 2. Looks like we have what? Angle, angle, side. Okay, so that works. That's definitely law of sines. When I was in college, oops, sorry. When I was in college, I kid you not, I would see this problem and I would immediately go, let's see, what do I got? What do I got? I got an angle. I got an angle. I got a side. Oh shoot, that's law of sines. Okay, I need to use law of sines. That's literally how I recognize that problem. So I would just see angle, angle, side, and immediately I would just think law of sines. So be aware of that, and just look back on the first, or I think it was the second slide where it's like the rules about angle, angle, side. Or okay, so take a look at that. All right, let's solve for s first. All right, so for s, here we go. Um, okay, so if you look at the opposite of angle S, right, there's S. So sine of 35 degrees over S, okay? And let's look, I get 33 degrees, and it gives me a given side, so I'm going to use him to kind of put as a reference for my formula. And again, I'm sorry if my 5s look like my S's. I could probably do like these little curvy S's. There you go, if that helps you guys. I don't know if that helps. So sine of 35 over S, and then we have sine of 33 degrees, our other reference angle, over 18. Cross multiply. So you should get S, sorry, that's a really weird S, times sine of 33 degrees equaling 18 times sine of 35 degrees. How do you get rid of a multiplying sine of 33 degrees? Divide. What you do to one side, you do to the other. So we have S equaling, okay, real quick in your calculators, be careful. Um, Let me make sure. 5, okay, divided by. All right, round to the nearest tenth again. and I got an approximation of 18.95, and I'll just round up, but when I do that, it'll move me up to the, yeah, move me up to 19. So you should get 19 for S. Now, for T. All right, so let's see. Angle T, again, what is the angle for angle T? You have to use the triangle sum theorem. So 180 minus 33 minus 35, and you should get 112 degrees. So don't forget triangle sum theorem is still a thing. Okay, do not forget it. So we have sine of 112 degrees over t, which is what we're solving for, and we can set it equal to a known angle that has an opposite side that's given, which I'll just go ahead and reuse sine of 33 degrees over 18. Okay, that way my rounding for s doesn't kind of mess up my answer for t. All right, cross multiply, just like the last example up here. All right, so you should get t times sine of 33 degrees equaling 18 times sine of 112 degrees. All right, how do you get rid of a multiplying sine of 33 degrees? Divide, just remember what you do to one side, half to do to the other, the law of equality. Okay, so in your calculator, you should have 18 times sine of 112. Oops, there we go. And then divide by sine of 33. And you should get, for t, 30.64, round to the nearest, so 30.6. That would work for t. So again, I kind of use what's given. I have an angle and an opposite side length. That's a great one for reference to solve for either s or t. Doesn't matter which one you solve first. Just be careful on rounding and what sides you're using. All right, so your turn number one. Same concept. Make sure you round to the nearest tenth, and you need to show all your work. All right, let me see how you're setting things up. Your turn number two. Again, show your work. Also, identify, is this angle, side? What is this? Side, is it side, angle? So make sure you explain why. All right, so there's your homework. More practice. And if you have any questions, let me know. And yeah, those coattails, man. Those coattails. Get it? Or living in your dad's shadow. It's like, wow, that's a crazy dad. All right, have a good one.